Hello, everyone. It's Thursday, September 34 p.m., right here in Baguio City. Hello from Vivi Stop Baguio. My name is Gabe Mercado, and welcome to the final episode, at least for now, of Out of This World Conversations. We've been doing this for every Thursday of September, right from Baguio City. And Out of This World Conversations is all about having conversations with adults and asking them questions, and it's adults with awesome jobs, out of this world jobs. And this show is really for kids to be able to ask questions from people and ask them how science, how tech, how engineering, how the arts, how math plays a role in choosing the jobs that they ended up with. And these conversations are geared towards kids because that's what Vivi Stop is all about. We're an after school science, tech, engineering, arts, and math center based in Baguio City. And we're all about letting kids fall in love with STEAM and also being a place for them to use the latest equipment, the latest technology to make things, craft things, invent things. So when it's already safe for kids to go out, you might want to take your kids to Vivi Stop in Baguio, or right below Mount Cloud Bookstore on Yanko Road corner, Brent Road here in Baguio. And we also have many different activities that are all online for now, and you can actually find out what they are through our Vivi Stop Facebook page at Vivi Stop Baguio, Vivita Philippines site, or through our YouTube channel, or through our website, vivita.ph. I think it's prophetic that today that our whole series is called Out of This World Conversations, because for our last episode, for now, for Out of This World Conversations, we're literally going to take you out of this world with our guest, who is an engineer, and he's working on this project right now that will literally take his eyes out to outer space and into orbit around the planet. Let us all welcome engineer Nathan Rosimo joining us for today's Out of This World conversation. Hello, engineer Nathan.
Hi Gabe, how are you?
Oh, we're good. We're really excited to be talking to you today. And you are an engineer and you're working on something exciting with Mula right now. Could you tell us briefly
Yeah,
what that is?
so Mula is a satellite that's used to take pictures of the Philippines mainly. So it is a spacecraft that will be in space and orbiting all around us. You said that this was going to be your last episode. That's very fitting that it's
For
called
now,
Out of This
yes.
World. Yeah. Wow. Yeah. Yeah, so
So
that's Mula. Yeah.
that's Mula. And a lot of you might be wondering, what, the Philippines sending something out into space? Well, we've actually been doing that for a while right now with the Philippine Space Agency, going on 2 years right now. And Mula is one of their latest involvements. And today we're going to listen to engineer Nathan on what Mula is all about, and all about satellites in space, all of that. And after that, we're going to ask questions. And today we've got five different reactors from Vivistop, and they'll be able to ask engineer Nathan questions as we go along. But if you're watching on our Facebook or on our YouTube channels, you can put any questions or any comments you might have about engineer Nathan's presentation or anything about space at all, and we'll be sure to answer those questions, or at least ask them during our question and answer portion with engineer Nathan. So, without further ado, I'm going to go backstage a little bit right now, and I'm going to give the floor to engineer Nathan.
Thanks, Gabe. So let me just share my screen. So today I'm going to talk about Mula, like Gabe said, and a little bit about what I do as a spacecraft engineer. So I named this presentation "A Little Space for Everyone" because I want people to realize that while space sounds daunting when you hear it at first, sounds like something only a few people do in their life. It's actually more accessible and closer to what you experience in everyday lives. And there really is something for everyone to get involved in the space industry. That's why I called it "A Little Space for Everyone." So before we start, I'd like to introduce myself. So I'm Nathan. I'm a spacecraft engineer for the Mula satellite. This was me a few months back in London. And a few facts about me: I graduated just last year actually from UP Diliman with a course in BS Materials Engineering. Um, I also like to do outdoorsy stuff outside of work. So I love to go hiking. I heard a lot of you are from Baguio, and this picture was taken at Mount Ugo, which is quite near Baguio. Um, I also do a lot of rock climbing and surfing. So I really like to be out there, experiencing nature by myself. So that's a few things about me. Now, to talk about what I want to share with you is satellites. So I think it's good to understand what satellites are. So the basic definition of satellites is anything really that orbits the Earth. And by orbit, we mean goes around the Earth. So the first thing that would come into most of our minds is the moon. So the moon is a natural satellite. But when we're talking about satellites, we're usually not talking about the moon. We're talking more about machines and man-made stuff like the International Space Station. So this is where astronauts go to live when they go to space. So if you've seen those videos of astronauts stumbling around in zero gravity, this is where it takes place in the International Space Station. So other satellites are like the NASA TESS, which is used to image um, planets outside our solar system. And there are loads of other satellites out there that are used for very different purposes. So orbits could be very different, and um, the closer you are to Earth, the faster you go around the Earth. So I think it's important that we emphasize that satellites go around the Earth multiple times in a day, as you can see here in the image on the upper left. So the International Space Station actually goes so many times around in a day that you could see it um, multiple times when you observe the night sky. So there are many types of orbits, each with its own advantages. So the most common orbit is the one closest to the Earth because it's easier to get to. So this yellow orbit here and the red and green orbits as well. So those are the most popular orbits for satellites. So satellites, like I've said, are usually a machine that is launched into space, usually by rockets usually, and moves around the Earth or another body. So the basic parts of a satellite, I'd say, are first its power source because it needs power to do what it needs to do. So it usually uses solar panels, as you can see here, to harvest energy from the sun, and it has batteries inside it to keep that energy. Another important part of satellites are the antenna, because there is no point in having a satellite out there if you can't communicate with it or if you can't see what it sees. So these are the two main parts of a satellite. Um, Another part that is very important are the scientific instruments. So this could be cameras if you want to take pictures of the Earth, or if you're like Hubble Space Telescope, which you want to take pictures of outer space and other galaxies out there. It could also be a radio unit or a antenna, so it could be used for communications and internet and things like that. So you could put anything you want on satellite um, as long as it could fit in there. That's basically the limit. Uh, so satellites come in all shapes. This is Sputnik 1, the first satellite in space. So it looks like a ball with legs. Actually, it looks kind of like a spider. Um, this is the gray satellite, which kind of, I'd say it looks like a Toblerone, and it's used to detect gravitational fields around the Earth. This is Landsat, which kind of looks odd to me. It's used to take pictures of the Earth as well. This is Geotail, which kind of looks like a cake. And this is another satellite which looks like it has an umbrella on it, but that's actually a very large antenna. So what I'm trying to say here is that there is no one picture of a satellite. They could all look differently as long as they fulfill their purpose or what they're built for. So they could also come in different sizes. This is Diwata 1. This is the first Philippine-made microsatellite. It was launched a few years back. I forgot when, but it's not in space anymore. It's actually um, deorbited. It's burned up in the atmosphere. So it's the size of a small balikbayan box, if I may say. So satellites can also be really huge. So these are the SES satellites, which are used for communications. So you can see the small person right over there, the one in a orange jacket. So that's how big these satellites could get. Um, and satellites could also be really small. So these are what we call Cubesats. So these are the Maya Cubesats, which we've launched just actually a few weeks back. They're currently in the International Space Station. They're called CubeSats because they're shaped like cubes, and they're really very small. They weigh about a kilogram to 3 kilograms, depending on how many cubes you stack on top of one another. So about the satellite that we're building. Oh no, not. So what are satellites used for? So satellites are mainly used for Earth observation. So if you've used Google Maps or Google Earth, you've probably seen pictures taken by Landsat. So that's what those are for, and they're used to track changes all around the Earth. We've used Landsat to see how the polar ice caps in Antarctica have shifted through time. So they could also be used for the weather. So in the Philippines, we're very familiar with bagyo and typhoons. And when you see videos like this on the news, it's probably taken by a space satellite. They could also be used for communication. So for internet, for calling someone on the phone, there's usually some satellites involved there. Or when using maps, when you connect your GPS or use location on your phone, you're connecting to multiple satellites at once, and it could detect exactly where you are on the surface of the Earth. So the satellite that we're currently building, the Mula satellite, it's the biggest Philippine satellite. It's around 130 kilograms. So just for comparison, our previous satellites, Diwata 1, Diwata 2, they were about 55, 56 kilograms. So this is almost 3 times as heavy as that. It has a multispectral imager, which it basically is a camera that can see more colors. So we could do more things with it. So one of the things we're planning to use it for is disaster monitoring. So this picture here is a picture of Taal Lake. If you might remember, just last year, no, yeah, that was just last year. It erupted and there was ashfall everywhere. So we could use images from satellites to determine where the ashfall is concentrated, and we could focus our efforts and help from the government into those areas. Um, they could also use it to monitor our bodies of water to see if the corals are healthy, if the water is clean, and we could also use it to monitor crop health. So Philippines is a very agricultural nation. We rely a lot on our plants for our economy. So it's very important that we use this to monitor the health of our crops, when to harvest, how much we could harvest. And it's not only used for crops, we could use it for tracking mining activities as well. We could also see deforestation, illegal logging, things like that, things that we would not see if we are down here on Earth. So finally, we could use the satellites to detect ships and aircraft all around us. Um, so just a comparison of how far we've come in satellite technology. This is what Diwata 2, the most recent microsatellite the Philippines sees. So the red spot there is what it can see at the specific time. So that's what it can image. But the Mula spacecraft can see almost 40 times the size of that. So it goes, as it passes through the Philippines, that's the amount of area it could see. So it could see 40 times the area of what the Wata 2 can see. So that's very important. I'd say it allows us to take more pictures of the Philippines in lesser time so we could get more information as quickly as we can, especially when there's natural disasters uh, where response time is very important. So let's go to what I do for work. So I basically am a spacecraft engineer. So spacecraft is anything, a vehicle or machine designed to fly in outer space. And engineers are people who design, build, and maintain machines. So spacecraft engineer is basically someone who design, builds, or maintains machines designed to fly in outer space. But the truth is, I can't build an entire satellite by myself. There's so many moving parts that I don't know how to do most of them. So within a team, we get roles. So what I really do for work is that I'm a thermal, radiation, and propulsion engineer. So those are three roles, which is bundled up into one job. So that's what I do. I do all three of those work. Um, so we'll go through what each one of them mean. So thermal engineering is something that relates to heat or temperature. So temperature is how hot an object is. So why do we have to pay attention to the temperature of a satellite? So it's basically because space is very harsh to satellites. It's very hot and it's very cold. So how cold is space? So we look at this graph. 100 degrees centigrade is where water boils. 75 degrees is your hot chocolate, so that's still quite hot. Our body temperatures is 37 degrees normally. Temperature in Baguio, which gets a little bit colder um, during good times of the year, it's 16 degrees, and water freezes at 0 degrees. So that's temperature inside your freezer. So that's quite cold right now, it isn't it? But it's still not as cold compared to space, which is around negative 270 degrees Celsius. So I don't expect you to understand how cold that is because personally I don't know what it feels like. I mean, I haven't even experienced 0 degrees Celsius personally, so I don't know what negative 270 degrees feels like. So that's how cold space is. But space is not only cold, it could also be hot. So when satellites are out there, they don't have the protection of the atmosphere. They don't have clouds. They don't have trees to keep them cool from the sun. So when they're going around the Earth, they get to really high temperatures when they're out there exposed to the sun. And then when they go back into the Earth's shade, they get really cold. Like I said, negative 270 degrees is the temperature of space. So imagine, it's like I said earlier, satellites go around the Earth multiple times in a day. Mula goes around the Earth, I think, 6 times in a day. So imagine if you had a laptop and you put it inside an oven, and then you put it in the freezer, then back in the oven. Imagine doing that 6 times in a day. That's going to destroy your computer. Now imagine for satellites that are experiencing this every single day, and satellites are built to last for 5 to 20 years. So imagine just how much heat and cold they are experiencing on a daily basis. So those are the things that I designed for as a thermal engineer. So how do we keep satellites cool? So you might see these pictures of satellites that look like they're from the future. They look very sci-fi, futuristic. They look very shiny with all this gold foil, gold or silver foil. And the thing is, it's there for a reason. These are called thermal blankets, and they are used to prevent heat from the sun from coming into the satellite. At the same time, they prevent heat within the satellite from getting out. So that's my job as a thermal engineer, is to prevent satellite from getting too hot and getting too cold so that everything inside the satellite, the cameras, the computers, survive their entire lifetime. So my next job is a radiation engineer. So radiation is energy that travels through space. Um, so radiation is all around us. It's passing through us right at this moment. So radiation is come in the form of waves. So that you have radio waves, you have microwaves, which you use to heat your food. Light is also a radiation, and so are X-rays. So the thing about radiation is that they carry energy within them. So as you go to the right of this graph, you get more and more energetic, you get more and more dangerous. So you can see here gamma rays. If you've heard of Incredible Hulk, like Dr. Banner, he was hit by gamma radiation, which turned him into what he is now. So gamma rays can be very dangerous. They could give you all sorts of sicknesses. Um, but what we experience in space, it's much more dangerous than that. In space we get cosmic rays, which is much more energetic than gamma rays. So these come from exploding stars like supernova, or even the Big Bang. The radiation we see throughout space is sort of a fingerprint of the universe. It gives us uh, a view of the past, because these radiation, they came from the Big Bang. Um, the sun also gives out radiation, especially when it has solar flares. It gives out really energetic particles. So the radiation in space um, is very intense, very dangerous. Um, this is a good idea or representation of what it looks like. But of course, we can't see it. Uh, it's invisible, but this is just how much radiation we are experiencing in space. So why don't we get hit by radiation right now? Why haven't we all turned into the Hulk? And the truth is, a lot of radiation does hit us, but it is filtered by our atmosphere. A lot of the atmosphere takes energy away from that radiation. And most importantly, we are protected by our Earth's magnetic field. So because of the Earth's magnetic field, we have like this donut shaped protection where the radiation gets trapped. You can see here the green and the purple areas, those are where radiation gets trapped. And the thing about this is that we are still open to radiation at the north and south poles. You can see here that we are not protected at these areas. And that's why we get aurora lights in the north and south pole. It's basically radiation hitting the atmosphere, producing all these sorts of lights. Um, so radiation is very dangerous to satellites because the computers we use are very intricate. Um, they easily get destroyed in other sense. Um, so we could get really nasty signals like this one. So this is a very noisy image. We don't want that, especially when we're taking pictures of stars or pictures of the Earth. If we get something like that, then we don't have a good image of what we want to take a picture of. So sometimes our radiation can also affect the memory of our computers. And on an extreme case, it could damage the computer. It could really give it a blue screen of death. And we don't want that because once we send the satellites to space, there's no way of repairing them. So if they run into some sort of trouble, it's gone forever. So that's how critical we have to think for radiation. So we protect against radiation by shielding. So shielding is just adding a block of aluminum because a lot of radiation is absorbed by aluminum and other types of metal. So we have to determine where we need to put shielding because this is also heavy. So we have to use them as little as we can, but we also have to protect the most sensitive equipment out there. Or we could use redundancy. So redundancy is basically instead of having one computer, it's having three computers. When you ask the computer, what's one plus one computer says one plus one is two. Another computer says one plus one is two as well. But the third computer, probably hit by radiation, says one plus one is three. But it uses this voting system. Two computers said one plus one is two. Therefore, it must be two. It eliminates the output from the radiation damaged computer. So this is used in all sorts of ways. It's a combination of a lot of different things to make sure that our computers survive the radiation in space. So my last job in the Mula spacecraft is a propulsion engineer. So propulsion is the action or process of pulling or pushing to drive an object forward. So this is based from the Newton's third law of motion. I think you will encounter this when you get to high school science, I think. And so it basically says that for every action, there is an equal and opposite reaction. So when you push on a wall, it pushes back on you. That's how it works. Um, we could see this much better in balloons. If you've ever blown into a balloon and not tied it, like you've just blown into it, and when you release it, the balloon flies the other direction. And why that happens is that the balloon releases air, which is the action, therefore the balloon must go on the other side. So this is Newton's third law of motion in action. So this is also how rockets work. Rockets release a very high temperature gas on one end, and then it accelerates on the other side. And we could use this uh, in our spacecraft, in our satellites, to help it move around in space. So basically, propulsion engineering is rocket science. So if you want to be called a rocket scientist, propulsion engineering is the answer to that. So it's really cool to be dealing with rocket science at work. Um, so this is a scene I really love from Wall-E, which perfectly explains how propulsion system in space works. So in space, you experience zero gravity or microgravity, as we call it. So you're just floating around in space. So when you release a gas, or here where Wall-E uses a fire extinguisher, when you release something in one side, you move the other way. So that's how propulsion systems on satellites work. That's how we are able to move around in space. So why do we want to move around in space? Why do we need propulsion systems in satellites? If we're just taking pictures of the Earth, why do we need to move around? So there are a lot of reasons for this. First is to change or adjust orbit. If you've seen the news of robots getting to Mars, getting to the moon, it's because they have propulsion systems that help it change orbit. So if you want to go farther or nearer the Earth, you use propulsion systems. Um, it's also used to avoid obstacles. Currently, I think we have around 6,000 satellites in space. About half of those are active, the other half are dead, so they're just flowing garbage around. So it's not unlikely that we might hit a satellite when we're up there. So we could use the propulsion system to move out of their way to save our spacecraft. And lastly, we use propulsion to deorbit. So the orbiting is basically killing the satellite. We push the satellite to go towards the Earth, and since it's moving at a very fast speed, when it hits the air in the atmosphere, it burns up. So you don't have to worry about any satellite hitting you because it will burn up in the atmosphere. Sometimes when you look into the night sky and you see a shooting star, it might actually not be a shooting star. It might just actually be a dead satellite that's burning up in the atmosphere. Yeah. So that's my job. I'm a thermal, radiation, and propulsion engineer. I hope you learned more about what I do. So what does it take to build and operate a satellite? So as you've heard, I do quite um, a lot of stuff myself, but it's still not enough to build a spacecraft. I still need to have an entire team with me to build a huge satellite. I really hope you get to speak to each one of my colleagues because what they do are very interesting and very different to what I do. You know, it really takes a whole team to build a satellite. Actually, this is my favorite part of being a spacecraft engineer is being amongst my colleagues because you're it's like being in class. It's like you're given a really hard problem to solve. You have all these people to bounce ideas off, to brainstorm on how to solve that one thing. And you're all working together towards a single goal. So if you want to build a satellite, you have to find yourself a team of really talented and really passionate people. So, what does a typical day for us look like? So, when you're designing the satellite, when you're in the first few months of making a satellite, there's a lot of maths and problem solving involved. Like you run into a lot of problems, really. Like, oh no, the solar panels get too hot. What can we do about it? Oh no, the imager, the camera gets too hot. What can we do about it? Can we add a little bit more thermal blanket here? Can we reduce its power and things like that? So you have to really try every solution you can think of. So it's a lot of maths and problem solving. It also involves a lot of testing. So this is my good friend Fadi. He's our power engineer, and he's looking into each solar cell individually to make sure they are not cracked. Because, like I said, once it's up there, you can't fix it. It's you can't touch it once it's up there, and it involves a lot of building. So this is our very talented technical lead and system engineer, Doc Julie Banatao. This is her building the Diwata 2, I think. Um, so it involves a lot of engineering and building and being creative. So it's a really exciting job for me. So what is the future of space in the Philippines? So I grew up uh, knowing that only NASA does really cool space stuff. That it's only the bigger governments, the large agencies who are able to put things out in space. But that has all changed recently with the advent of smaller satellites. So even universities, even small groups can now launch satellites to space. So we are currently at this point, Mula, and you can see there are still loads more satellites that we are planning to launch in space. So we also have the Philippine Space Agency, which is a consolidated effort to help tap into our natural, into our local industries, and to help develop the talent pool of engineers in the Philippines. So it's very exciting to be excited about space right now because you have all these avenues. You have PILSA. It's much more achievable, I'd say, than a few years back for someone who dreams about space. So if you want to be an astronaut one day, don't stop dreaming about that because it really is possible in this day and age. So how can you be a part of it? So I think it's very important to focus on your studies. It's really good to have a problem solving mindset. I hope that you are always um, willing to learn. I hope that you enjoy learning and that you like tackling very complex problems and finding the answers to questions that you just think of, like why is the sky blue? How does a car work? Um, why does my food get cooked when I put it in the microwave? So it's being curious and being excited for learning, just really like wanting to know how things work. I think that's really important if you want to be a spacecraft engineer. But what I really like telling people is that you don't only have to be an engineer to be part of space. You could be a lawyer and be part of a space agency. You could be a geologist. We need geographers, biologists, chemists, um, who else? Businessmen to help interpret what we are taking pictures of. We might be able to take pictures of the Earth, but we don't know what to do with it. And we need scientists to tell us what these pictures mean, and we need politicians. So you could be a president, you could be a senator, and still be part of a space agency by helping make laws, make changes so that uh, what we get out of these satellites can be solutions to real world problems. So that's why I really like to say there is a little space for everyone. So thank you, and that's my presentation. I hope you learned so much more about spacecraft engineering and the Mula satellite in particular. So thank you.
Yes, we did. And you should have seen we have a private chat window and it's blowing up with many, many different questions And then we also have some questions that were sent ahead. Maybe we'll do one question first that was sent ahead, and then we're going to let the kids in and ask their own questions. The question is, how do satellites not bump into each other when they're out in space?
So like I said earlier, we have propulsion systems.
Right.
So um, we know where the satellites exactly are in space. So even though there are 3,000 of them, most of the agencies around the world know where they are. So before they bump into each other, they send an alert to space agencies like, oh no, the Wata one is going to bump into this satellite, or there is a space junk in the way of your satellite. So they send those signals to us, and then we plan a propulsion firing. So we turn on the propulsion system, move it out of the orbit a bit, and then after it's past that, we put it back to where it should be. So it's kind of like that. Yeah,
Does it still happen though na may nagbabanggaan?
yeah, it still does, but it's not as often as you think, because even though there's 3,000 satellites up there, it's a really huge space. Space ranges from 100 kilometers to 30,000 kilometers. So
All right.
that's a yeah, that's a lot of space for satellites to cram into. So it's not as common as you think, but it still is possible. Yeah.
All right. Yeah, because three-dimensional nga pala yun. There's
Yeah.
the height and then the actual space
Yeah.
and the width of it. We're gonna let our Vivi stop kids in. We call them Vivinots actually,
Really
as they
nuts.
explore their knowledge, and we're gonna have many of them join us. And if you have a question, you can raise hello from everyone. If you want to be the
Wall.
first, you can raise your hand and I can call you. Sari, go ahead.
How do you blast satellites to space?
That's a really good question. So we use rockets. Um, but the thing is, there are only a few places on Earth that launches rockets. So there are some in India, some in Russia, some in the United States. So what we do is that we piggyback on these rockets. So you could have a rocket with 10 satellites within it. And then after it's gone into space, they all let go of the rocket and go their separate ways. So that's how we use rockets to go into space.
And then lately, I think we've been, at least for the last one, we used the JAXA or the Japan one. We
Oh
hitched with
yeah,
that
the
one.
Japan one. Yeah. So
Yeah.
the Cubesats, on the other hand, they are launched from the International Space Station, I think. So it has
Yes.
the Cubesats have to go to the International Space Station first, then they're released there individually.
All right. So we have more questions. Up next is Glory to the Wall Empire. Go ahead, Glory to the Wall Empire.
Okay, so my question is, what happens to the rocket engines after you use them? Are they reusable or do they just float in space as more dangerous space debris?
Right. That's a really good question. So the lower parts, so you have very different stages in a rocket. So you have the first stage, which is used to go up into the atmosphere. So if you've heard of SpaceX, they're now recycling these rockets because they are very expensive. And when you can recycle them, you save a lot of money on the next launch. So the first stage usually falls back to the Earth. They're recycled, or they are planned so that when they fall back, they fall into the ocean and don't hit anyone. The upper stages, though, they either burn up in the atmosphere or they float around in space like space junk, as you said. But
Oh, so
usually they burn up in the atmosphere. Yeah.
that's a lot of
Thanks.
that's a lot of
Yeah,
math
that's a lot of,
predicting where it will be.
yeah, it
Um,
is.
Mazzy, go ahead.
So, do we pay pamasahe in the piggybacking?
Sorry.
Do you pay pamasahe when you piggyback?
Oh, yeah. It's very expensive, actually. That's why there are like 10 satellites or more, you could have you could have many satellites in one rocket, so that you could all split the cost of that rocket. So it's like riding a bus instead of taking a car. You share the entire rocket with a lot of different projects, so you save up on that. But it's very expensive.
Yeah, you can actually, if you're rich enough, you can
Yeah,
actually send whatever you want in space. Yeah,
yeah,
if
that's
you just pay
right.
the pamasahe. So
Yeah,
if you wanted to send a cat in space and you're rich enough to do it, you could actually do that. Probably won't
yeah.
survive, but we have Wally Tommy Init fan. And then if Chloe has a question, we can go to Chloe, and then before going to Sari again. But Tommy Init fan, go ahead. Wall Tommy Init fan, go ahead.
Well, what do you do if like one of the satellites has like a malfunction? Do you like you still have control of it, or you just leave it to be in space?
um, that's a really good question. So we plan for things like malfunctions. We have things such as failure detection and recovery. So what happens is that when something malfunctions, we receive it here at the ground station. We immediately know, oh no, there's something wrong, and we investigate what happened. And usually, the satellite goes into a safe mode where it sort of turns everything off, like it shuts down and it just
Ah,
tumbles in space. Yeah. And then when we have decided, we have found out what happened to it, how to recover it, that's where we send code back up to the space to fix it, and then it becomes operational again. So a lot of things are going behind. We actually we're not sending it up there with nothing, with no backup. We have coded for everything. We know how everything works, things like that.
So if aliens were true, so aliens will just see a random satellite broken. Okay.
yeah, have you
Yeah.
prepared for aliens?
Aliens on. Sadly, no. uh,
Okay. We're
yeah.
gonna go to Chloe, Sari, and then Glory to the Wall Empire. Okay, Chloe, do you have anything?
Yeah. How about how long is it before a satellite gets destroyed in space?
Ah, nice.
Okay. So usually when it's in the low Earth orbit, which is around 100 kilometers to, I think, about 1,000 kilometers, it usually takes about 25 years or more to drift back to the Earth. But when it's farther than that, it doesn't really go back into the Earth. So it could stay there forever if it's far enough. But I think there's a rule right now that satellites should should go back into the Earth, or they should move to an orbit that no one uses within 25 years. I think they've
Wow.
set that rule very recently so that we avoid space junk uh, just piling up in space. Yeah,
And
that's a really good question.
if you want to freak out your parents, you can remind them that when we were kids, we were always afraid of something called Skylab falling into our
Skylab.
heads. It was a space station that we were afraid that they were afraid of that would fall somewhere. They couldn't control it. So tell them you know about
Really?
Skylab.
I didn't know
So
that.
yeah, well, I'm older than you. Sorry. Go ahead, Sari.
So what is the satellite called? Because you just called the shapes of them. It looks like okay, just said that. So what's the name of
Yeah.
those satellites?
So the one that looks like a ball, that was Sputnik. The one that looks like a triangle, like the Toblerone, it's called Grace. Um, the one that looks like a cake, it's called Geotail. So they have very different names for satellites. It depends on what the agency calls it. We called our satellites Mula because it's a Tagalog word and also means multispectral land assessment, things like that.
All right. Glory to the Wall Empire. You have a question?
I do. What is the purpose of the satellite? How long did it take to develop the satellite?
Sorry, can you repeat
Parang,
that again?
what is the
How
purpose
long
of the satellite? Yeah.
and how
Okay.
long did it take to develop it?
That's
Parang
a
thesis
good.
defense ang tanong. Go ahead, Nathan.
So the satellite is mainly for taking pictures of the Philippines. So we use it for monitoring disasters, for crops, even our oceans. We use it to monitor that. So um, I think we have to understand that Mula is still not there, still not up there yet. It still hasn't been built. We only are in the preliminary design phase. So it usually takes about um, 1 year to 2 years to completely build a satellite because you have to go through all these tests and reviews to make sure that the satellite design is good, to make sure it works, it does its job, because they are very expensive machines and you want them to work as they are.
All right. Before we go to Sari again, we're gonna get a question from our Facebook site. Carlon Santos asks, "What if you bought a round trip ticket to space, but you lost the other ticket going back to Earth? Are you going to be tossed outside the spaceship by the crew?"
Sadly, I don't know the answer there, but I'm pretty sure you can't go to space and not come back right now. Yeah, so it, I'm really not sure about that. It's a really good question, though.
Actually, that's a
Yeah.
good question. Has any human ever been lost in space? Has that ever happened? Parang hindi pa naman,
I,
ano?
I don't think it has, yeah,
Okay.
because I think agencies will get shut down if that happens, you know.
Mm-mm. But it's
Yeah,
different if wala kang pamasahe right
yeah,
there.
you just get left there.
Sari, you had a question, Sari. Go ahead, Sari.
How does a satellite cost? Because I heard about satellite 6 years of building it costs millions.
Yeah, how much does a
Yeah.
satellite cost?
Um, so they could range from a few millions to, so the Mula satellite currently we're valuing it around 1.8 billion pesos.
Whoa.
So it could even go to the trillions if you're making really huge satellites. So they're very expensive.
And a cube satellite is several millions.
I think it could go to the, actually, I'm not sure. I have to get back to you on that. But it could go to the
Okay.
millions if you want to launch it into space because you still have to pay for the pamasahe.
The pamasahe.
Yeah, the pamasahe.
Mazzy, go ahead.
So this is for the Mula. Um, how many watts of energy does the satellite need? And also the,
How many?
How many watts of
how many
energy?
watts?
Ah, actually, I'm not sure about that. I'll get back to you. But we do have a number for that. I just don't have it in my mind right now.
Wow, it's a
I'll
tough
ask our
thesis.
power engineer. Yeah.
Tough thesis defense panel. We're gonna go to Glory
Yeah.
to the Wall Empire and then Wally, Tommy in it after that. So Glory to the Wall Empire. Go ahead.
Hmm. Okay, so my question is this government funded, or if it isn't, who is funding this?
Okay. I didn't expect that question. So the Mula satellite will be we're hoping it would be funded by the government because it will be the government that uses it. But some satellites can also be funded by private companies that use their data. So if, for example, you make a an app like Google Earth and you have to buy the pictures from somewhere, so you pay a company to build a satellite, and that becomes funding. But for the Mula, I think we're looking primarily into government funding, but we're also looking for people like private companies would pay for its services.
And somewhat related, what does MULA stand for again, and when will it be launched? When would
Okay,
we hope
so
for it to be launched?
yeah, we hope for so it stands for Multispectral Unit for Land Assessment. So yeah, multispectral means a lot of colors, so it could see more colors than previous satellites, which makes it more usable. Multispectral unit for land assessment. It will hopefully we could launch it by 2023. Yeah, so that's the plan. 2023.
That's soon. So
Yeah, that's very soon.
That's very soon. Wally, Tommy in it, and then Sari.
Has a satellite has entered a has a satellite destroyed by a black hole?
Has there been a satellite destroyed by a
Destroy.
black hole?
I don't think so. Yeah, I think the farthest satellite we currently have is the Voyager 2. So it's twice the distance from Earth to Pluto as of now, and it's still going far. But I think we can only communicate with it until 2025. After that, it's lost forever because we can't send our signals that far. And
Wow.
black holes are many galaxies away. So I don't think we've ever gone that far. Yeah.
Wow. So
Yeah.
Sari, glory to the wall empire, then Mazi. Go ahead, Sari.
Um, what does the each satellites do?
What does each
Each sat
satellite do?
okay. So they could be very different. They could have really different roles. So like Mula, it is used for taking pictures. You also have Landsat that also takes pictures. And you have some satellites that take pictures of other planets, other galaxies. You can have satellites that are used for internet, like Starlink, which
Huh.
is used to give 5G internet to more people. You can also have satellites used for telephones, for weather. So a lot of things, really.
Glory to the wall empire, and then Mazi.
Okay, since I ran well, never mind. What oxygenator did you use for the satellite? And by
Ooh.
oxygenator, I mean for the rocket fuel. What did you use in place of oxygen for the rocket fuel?
Wow. You're talking
Um,
to the
uh,
propulsion guy, so we'll see.
yeah. So just on the Mula, we're not using any traditional fuel. We're using water for fuel. So it's
Whoa.
so it's one of the first satellites, one of the few satellites to use water as fuel. So we're going to superheat it to superheated steam and use that as fuel.
That is super cool. And it's so
Yeah.
cool that you're talking to the propulsion engineer of Mula right here,
Yeah.
and he could actually ask that. Mazi, go ahead.
So, how much water do you need so that you
How
can
much water?
launch the,
Uh,
you know,
I'm
the
actually
moon?
not sure. So I don't have the exact numbers in mind right now, but I think I need to clarify that we're not using the water propulsion system to launch it to space. So we're
Yeah.
piggybacking on a rocket that uses traditional fuels like that burns really good. And then when it gets to space, that's where it uses the water to move around. I don't think you can use water to get out of the Earth's gravity because it's too
Yeah,
too
not yet.
strong. Yeah, not yet, not yet. Yeah,
And probably too heavy.
yeah, probably too heavy too.
Do you exchange information with other agencies such as NASA when you hit a roadblock in the design? Is there a governing body that approves if and when you can launch a satellite, monitor all the satellites in space, make regulations, etc.?
Okay, so do you exchange information? That question first, with other agencies. So most likely no. So you come up with um, come up with solutions yourself, or you take inspiration from previous projects that NASA has launch. So they might publish their design. Oh, they use that. Oh, maybe we could use that for these satellites. So the thing about space engineering is that it's very, uh, how do I say this? It's very restricted because it could also be the technology we use for space, we could also use for defense. And that's really dangerous to just keep information flying around. So we usually contain the information within um, the agency that builds the satellites or the company that builds the satellites, and we come up with solutions ourselves. So is there a governing body that approves if and when you can launch a satellite? As of if, I'm not sure, but when, it depends on the launch agency. Like you have to fit your satellite to their schedule. It doesn't work the other way around unless you have the money to pay for the entire rocket yourselves. Yeah. So there is an agency that monitors all the satellites in space. I think this is a joint effort by a lot of the agencies because each agency knows where their satellites are and they have to relay that information to other people. For the regulations, I think there's an there's a group with United Nations that makes the regulations.
And
Yeah,
hey, if enough of us are interested, we can try and see if there are other kids from the other Vivi stops all around the world. And
yeah,
we could try and see if we can launch a small cube satellite,
yeah. That's
cooperating
very
between,
interesting.
yeah, cooperating between Vivita Philippines, Vivita Japan, Vivita Estonia, Lithuania, New Zealand, Singapore, Hawaii. It could be. It's worth
Yeah.
exploring. I believe we have Sari, and then Sari is next. Go ahead, Sari, and then Mazi again, and then Glory to the Wall Empire. Go
Um,
ahead, Sari.
okay, so how does the satellite says I'm gonna bump to another satellite? How is he gonna warn you guys?
Yeah, is there a warning system for satellites if they're on a collision course?
So there is no warning satellite. So the satellites doesn't know if it's about to bump into something else. We know that it's going to bump into something else because we know exactly where they are. So when we see that their orbits are going to pass by one another, we know that from the ground, but the satellite's not going to tell us that. The satellite will just tell us where it is, and we could see how they are all moving up there.
Very nice. Mazi, go ahead.
So this is for the mula. So since I going to be a photography photographer slash videographer when I grow up, I'm just wondering for the mula, it always takes pictures. So what's the max resolution of the camera?
Ganda.
That's a really good question. So its maximum resolution is what we call a ground sampling distance. So its resolution is 5 meters. So when you measure 5 meters here in the ground, that's 1 pixel in the camera up there.
Oh,
So I that's still a high resolution for a satellite. But say 5 meters, I think my room is 5 meters. So when you take a picture of my room from outer space, it would just be 1 pixel.
1 pixel.
Yeah, so that's the resolution of the camera.
Oh, and syempre, yung mga tanong ko, so pedestrian, wow, kita kaya bahay ko ng mula from
Yes,
space?
so as long as it's bigger than the 5 meters, it's going to appear more than a pixel in that
I
picture.
see.
Yeah.
For something like Google Maps,
Hmm.
or yeah, the things that we use and we're most commonly exposed to in terms of satellite imagery, mga ilang kaya ang resolution nun?
So those could range, I think, about 10 meters to 30 meters resolution.
Ah,
The thing about this is kahit na it's smaller than 10 meters, it won't look like a single pixel because
right.
the camera will smooth it all out. So you can still see features even though it's smaller than the resolution.
I see. Well, we have time for just about one more question from the panel because believe it or not, we've been on R already. Chloe, go ahead. You have the last question.
Uh, can you like if the satellites moves the picture out, can you like see humans from space? Yeah.
See
Nice.
humans from space. I think you can, but you have to have a really high resolution camera for that. So usually the cameras that can see humans are have resolutions of 1 meter or
Wow.
even less than 1 meter, like zero point 0.5 meters. And you need to have really huge cameras for that. But the Mula is just 5 meters, so most more likely than not, you won't be able to detect every single human, but you would be able to see where people are, if that makes sense.
Wow. And with that, I am heaving a
Yeah.
sigh of relief because part of me is thinking, can they see my bald spot from space? And I think the answer is no, they won't be able to see my
Yeah.
bald spot from
Not
space.
yet.
And with
Not yet.
not yet, at least not with Mula, at least
Not
not
with
with Mula
Mula.
yet.
Yeah.
So we'd really, really like to thank you, Engineer Nathan Rosimo. Let's give him a round of applause, please, at least through the camera, for being able to share with us all about the Mula satellite project, and giving us interesting things to look forward to. And we're crossing our fingers that we can all send it up into space by 2023. If you Thank you, engineer.
Thank you so much. I've really learned a lot from your questions. It's very interesting, and I hope you also learned a lot from my presentation. I hope some of you go into the space industry. Hopefully, some of you build the next satellites for the Philippines. Yeah. So thank you so much.
Abs- Thank you, engineer. And everyone, kids included, especially those watching at home, it's never been more possible to have a
Yeah.
job in the space industry than now with the Philippine Space Agency and all the efforts happening. So thank you again, Engineer Nathan. And for everyone at home, this is the last of our September run of Out of This World conversations. And these are conversations brought to you by Vivi Stop Baguio, where we talk to adults with awesome jobs and we ask them awesome and tough questions from the point of view of young people. And this is brought to you by Vivi Stop Baguio or Vivita Philippines. We are a makerspace. We are a STEAM, Science, Tech, Engineering, Arts, and Math Center just for kids, where we aim to incubate the next generation of inventors, creative thinkers, and makers who want to experiment and do things to make our country a better place to live in. And we've got so many things lined up for you, especially over the next few weeks. Starting this Saturday, we're actually going to launch something called Tinker Time. And Tinker Time is this is actually the second edition of Tinker Time. We did this a few months ago, and this is where we send kids who sign up small surprise kits like the one that we have, and we're going to send out um, starting tomorrow. This is Tinker Time Spooky Edition. It has materials that are a surprise. We won't tell you what they are. And then on Saturdays between 3 and 4 p.m. for August, we're going to, for September, for October, I'm sorry. I'm a little lost when it comes to the calendar. We're going to have sessions over Zoom where we make things. It's all about making things, and it's a surprise. We were supposed to have our first stop motion session this Saturday, but we've postponed that, and we have a surprise sessions. We have a surprise session in store for those who signed up, um, and you need to pick up your kit either tomorrow or by Saturday morning. This is happening all throughout October, every Saturday, and this is going to end with our Vivistop Baguio Fright Festival Film Festival, and this is happening on the last day of October, where we have a film festival of films made by our Vivinots, our Vivistop kids. Uh, Anything creepy, anything spooky, all under 5 minutes, and we're gonna watch it for Halloween. So we hope you're excited for that. If you want to sign up for it, you can check our social media pages on Facebook, on Instagram. The details are there. You just have to send us an email and we can sign you up for it. So, and we also plan to be active uh, also in November during the Mandeko Quito and the Ibagyo Creative Festival month. We're going to be active, and we hope that by then things will be a little bit safer for everyone and we can go out a little bit. So, with that, thank you so much for being with us. Thank you so much for participating in Out of This World conversation. My name is Gabe Mercado. We'll see you online. Thank you. This is Vivi Stop Baguio.